Have you ever looked up at the night sky and wondered, where did all of this come from? The stars shining above, the moon glowing in the distance, the galaxies scattered across infinity. Did they always exist? Or did everything, time, space, and reality itself, begin from a single spark? Close your eyes for a moment and try to imagine nothing. No sound, no space, no stars, no light. Not even darkness, because even darkness needs space to exist. There was absolutely nothing. And then something happened. Before we dive into this incredible story of creation, make sure to subscribe to our channel, because what you're about to hear will completely change the way you see the universe. This is the story of how everything began. This is the story of the Big Bang. Scientists believe that around 13.8 billion years ago, the universe was born from an event we call the Big Bang. But the name Big Bang is a bit misleading because it wasn't really an explosion in space. It was the sudden expansion of space itself. In the beginning, everything that exists, all matter, all energy, even time and space, was packed into a single, incredibly small, unimaginably dense point. We call this the singularity. It was smaller than an atom, hotter than a trillion suns, and denser than anything we can possibly imagine. Then, for reasons we still don't fully understand, that singularity began to expand. Not slowly, but in a cosmic burst that happened in less than a fraction of a second. This moment is known as the birth of the universe. In the very first instant, less than a trillionth of a second after the Big Bang, the universe expanded faster than the speed of light. This phase is called cosmic inflation. Space itself stretched, carrying everything with it. What was once smaller than a point became the size of galaxies, and then even larger. During this time, the universe was a sea of pure energy, a glowing, chaotic storm of light and heat. Temperatures reached unimaginable levels, trillions of degrees, hot enough to break apart everything into its smallest pieces. No atoms, no stars, not even particles yet. Just energy. But as the universe kept expanding, it began to cool. Energy started transforming into tiny particles, quarks, electrons, photons, and within moments, those quarks joined together to form protons and neutrons, the building blocks of all atoms. This was the first step towards everything that exists today, the creation of matter. About 1 second after the Big Bang, the universe was already the size of a galaxy. The first few minutes were the most crucial ones in all of cosmic history. In this brief window, the universe cooled enough for atomic nuclei to form. Protons and neutrons combined to make the first elements, mostly hydrogen and helium, with a tiny amount of lithium. At this point, the universe was still a glowing fog of charged particles and radiation, like a bright soup of light and matter. If we could have seen it then, it would have looked like a blinding fireball filling all of existence. But for hundreds of thousands of years, light couldn't escape. Photons, the particles of light, kept bumping into electrons, scattering in every direction. The universe was bright, but no one could see. Then, something extraordinary happened. About 380,000 years after the Big Bang, the universe had expanded and cooled enough for electrons to combine with atomic nuclei, forming neutral atoms. For the first time in history, light was free to travel. This moment is known as recombination, and the light from that moment is still traveling through space today. We can still detect it as a faint glow called the cosmic microwave background radiation, or CMB. It's like a baby picture of the universe, a snapshot of the moment when light first escaped the fog. That ancient light has been journeying across the cosmos for 13.8 billion years. And today, we can capture it with special telescopes. When scientists look at the CMB, they're literally looking back in time to the very beginning of everything. Now gravity, the most patient sculptor of the cosmos, began to take over. In that early universe, matter wasn't spread perfectly evenly. Some areas had a little more matter, some a little less. Over millions of years, gravity pulled the denser regions together, slowly forming massive clumps of gas. These were the first seeds of galaxies. Inside these clouds, pressure and gravity worked hand in hand. Hydrogen atoms were crushed so tightly that nuclear fusion began, and the first stars were born. These early stars were enormous, far larger than our sun, and burned through their fuel in just a few million years. Inside their fiery hearts, new elements were being created: carbon, oxygen, iron, the very ingredients for life. When these first stars exploded as supernova, they scattered those elements across the universe. From that stardust, new generations of stars formed, along with planets, moons, and eventually. So, in a very real sense, we are made of stardust. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was forged in the hearts of long-dead stars billions of years ago. You are literally made of the universe itself. Every atom in your body once existed inside that tiny singularity, the same singularity that gave birth to the cosmos. Think about that for a moment. You're not just in the universe. You are the universe, experiencing itself. The Big Bang wasn't just the beginning of matter and energy, it was the beginning of time. Before that moment, there was no before. No clock was ticking. The very concept of before didn't even exist. This is one of the hardest ideas for the human mind to grasp. We are used to thinking in terms of cause and effect. Everything must come from something. But when it comes to the Big Bang, that rule breaks. The universe doesn't seem to have a cause outside of itself. It simply began. Maybe it was triggered by a quantum fluctuation, a random event in a sea of nothingness. Maybe there are other universes, and ours was just one bubble that popped into being. Or maybe the question itself, what happened before, doesn't even make sense. Whatever the truth is, one thing is certain. That moment, the Big Bang set everything in motion. Every galaxy, every star, every world, every living being, all of it traces its origin back to that first instant. When we look up at the night sky, the light we see has traveled for billions of years to reach us. The stars we admire tonight might not even exist anymore. Their light is a ghost from the past. Each photon, each tiny particle of light, is a messenger carrying the memory of creation. So when you stare into the stars, remember, you're not just looking at space. You're looking into time. You're witnessing the history of everything unfolding right before your eyes. And yet the Big Bang was not the end of the story. It was just the first chapter. Because as space expanded and stars formed, something else was happening. A hidden force was shaping the fabric of the universe, bending light, stretching time, and weaving reality itself. To truly understand how the universe works, we must go beyond the explosion and learn how space and time are connected. In the next chapter, we'll dive into one of the most mind-bending discoveries in all of science: how time, space, and gravity are not separate things, but threads of the same cosmic fabric. Have you ever looked up at the night sky and felt small? Just for a second, staring at those countless twinkling stars, you realize how tiny we are. Every point of light could be another sun, with its own planets, moons, and maybe. But what if I told you that what we see, even with the best telescopes, is just a fraction of what's really out there? Before we go deeper into this cosmic ocean, make sure to subscribe to this channel so you don't miss the next chapters of our incredible journey through the universe. Because what's coming next will truly change the way you see everything. Now, let's begin our journey beyond our own galaxy. When you stand under the night sky, the Milky Way stretches like a river of light across the darkness. It's beautiful, silent, and infinite, or so it seems. But in truth, what we see as a glowing band of stars is actually our galactic home, the Milky Way galaxy. It's a spiral galaxy made up of more than 200 billion stars and stretching around 100,000 light-years across. To cross it from one side to the other, even traveling at the speed of light, would take 100,000 years. Just think about that. Light, the fastest thing known to us, would take 100 millennia just to cross our own galaxy. Now, imagine. We are just one of billions of galaxies. Let's zoom out. Our sun sits quietly on one of the spiral arms of the Milky Way, about 26,000 light-years from the center. At the heart of our galaxy lies something mysterious and terrifying, a supermassive black hole known as Sagittarius A*. It has the mass of over 4 million suns, and it controls the motion of everything around it. Every star, every nebula, every bit of cosmic dust in our galaxy is moving in a delicate dance, bound by gravity to this invisible monster at the center. Now here's something fascinating. The Milky Way itself isn't standing still. It's moving through space at nearly 2.1 million kilometers per hour, spinning like a giant cosmic disk. Everything you see around you, the stars, the planets, even you are part of this enormous motion. We are literally passengers on a galactic ship sailing through the universe. But here's the shocking part. Even our gigantic galaxy isn't alone. In the vast darkness, the Milky Way has neighbors. Closest to us is the Andromeda galaxy, another spiral beauty even bigger than ours. It's around 2.5 million light years away, meaning the light we see from it tonight actually left that galaxy. 2.5 million years ago, when early humans were still learning to use tools, when you look at Andromeda through a telescope, you're not just seeing distance, you're looking into the past. And one day, in about 4.5 billion years, the Milky Way and Andromeda will collide. It won't be an explosion like you might imagine. It will be a slow, cosmic dance lasting billions of years. Stars will pass through stars, galaxies will merge, and a new, massive galaxy will be born. Astronomers already have a name for it, Milkomata. So, even galaxies are not eternal. They are born, they grow, they merge, and they die, just like everything else in the universe. Now, step back even further. Our Milky Way and Andromeda are part of a small family of galaxies called the Local Group, about 50 galaxies in total. Most of them are small, faint, and irregular, like dwarf galaxies orbiting around the bigger ones. All of these galaxies are held together by gravity, forming a small island in a sea of infinite darkness. But beyond our local group, there are clusters upon clusters of galaxies, each cluster containing thousands of galaxies like ours. For example, we belong to the Virgo supercluster, which itself is part of an even larger structure, the Laniakea supercluster. Stretching over 500 million light years, try to imagine that scale. It's almost impossible. If the Earth were a grain of sand, the Milky Way would be the size of a large city. The Laniakea supercluster would be the size of the entire planet Earth. And yet, it's still not the biggest thing out there. When astronomers look deep into space, they see filaments, gigantic threads made up of galaxies and dark matter, connecting clusters like a cosmic web. Between these threads lie enormous empty regions called voids, where almost nothing exists. No stars, no galaxies, no light. This entire structure, the cosmic web, is the skeleton of the universe, a vast 3D map showing how matter has spread out since the Big Bang. But here's what's truly mind-blowing. No matter how far we look, there's no edge. The universe doesn't have a wall or a border. It's not like a sphere sitting in space. Space itself is the universe. Where does it end? We don't know. Some scientists believe the universe could be infinite, going on forever, never looping back, never ending. Others think it might be curved, like the surface of a balloon, finite but without edges. Whichever is true, one thing is certain. We have never seen the full picture. Let's pause for a second and think about what that means. Every star you've ever seen, every galaxy captured by the Hubble telescope, every light in the night sky, all of it exists in a tiny observable patch of the universe. Beyond that patch, there could be countless other galaxies, stars, and maybe other civilizations we can't even detect yet. It's like standing on the shore of an infinite ocean and realizing you've only touched a single drop. Imagine standing under a sky filled with stars, realizing that for thousands of years, humans had no idea what those lights really were. Were they holes in the heavens? Were they gods? Were they fires burning in the distance? For most of human history, the sky was a mystery, a beautiful, unreachable ocean of light. But everything changed when we started asking one simple question. How far are those stars? Before we dive into this mind-blowing journey, make sure to subscribe to the channel so you don't miss what's coming next. Because once you understand how we measured the universe, you'll never look at the night sky the same way again. Let's begin our journey from the first curious eyes on Earth to the most powerful telescopes ever built. Thousands of years ago, the night sky was the world's first map. People used the stars to travel across oceans, to tell time, and to plant their crops. But no one truly knew what those stars were. Even great thinkers like Aristotle believed the Earth was the center of everything, the fixed point around which all stars and planets revolved. To ancient people, the universe was small, like a dome over Earth, decorated with tiny shining dots. But curiosity doesn't stay silent for long. Around 1543, a man named Nicolaus Copernicus challenged everything we believed. He said something revolutionary. The Earth is not the center of the universe. Instead, it moves around the sun. At that moment, the idea of the cosmos expanded, not just in science, but in imagination. Then came Galileo Galilei, the man who turned a simple telescope toward the sky and saw the impossible. He saw that the moon wasn't smooth, that Jupiter had moons of its own, and that the Milky Way wasn't a cloudy mist. It was made of countless stars. For the first time, humanity realized the sky was not perfect or divine. It was real, physical, vast. Still, no one knew how far the stars were. They could be just beyond the planets, or maybe trillions of miles away. The scale of the universe was still a mystery. In the 19th century, astronomers made a breakthrough using something called parallax, a simple geometric trick. They noticed that as Earth moved around the sun, nearby stars appeared to shift slightly against the background of distant ones. It's like your thumb seems to move when you close one eye and then the other. By measuring this tiny shift, scientists could finally calculate the distances to stars. And what they found was shocking. Even the nearest stars were unimaginably far away. 1 light year, the distance light travels in 1 year, is about 9.46 trillion kilometers. The nearest star, Proxima Centauri, is over 4 light years away. That means the light we see from it tonight actually left that star more than 4 years ago. Every glance at the night sky is a look into the past. But the real revolution came in the early 20th century. A man named Edwin Hubble looked through the largest telescope of his time, the Hooker telescope at Mount Wilson Observatory, and discovered something extraordinary. Those faint clouds in the sky, once thought to be nebulae within our own galaxy, were actually other galaxies, each containing billions of stars. That discovery shattered everything we thought we knew. The Milky Way wasn't the entire universe. It was just one island in an ocean of galaxies. And then came the final blow to our old understanding. Hubble noticed that the light from these galaxies was redshifted, stretched toward the red part of the spectrum. This meant they were moving away from us. The farther away a galaxy was, the faster it was receding. The universe wasn't static, it was expanding. This single discovery changed everything. If the universe is expanding, then it must have once been smaller. So small, in fact, that it all came from one point. And that point was the Big Bang. From that moment, the quest to measure the universe became a race through time and technology. Scientists built radio telescopes, space telescopes, and even satellites like Hubble, WMAP, and Planck to measure the faint echoes of that first explosion. They discovered that the universe is 13.8 billion years old, and the edge of the observable universe lies about 46 billion light years away in every direction. But notice that word observable. It doesn't mean that's where the universe ends. It's just the farthest we can see, because beyond that, light hasn't had time to reach us yet. There could be infinitely more out there, galaxies, stars, maybe even other universes hidden beyond our cosmic horizon. Now think about what that means for us. Humans, fragile, tiny creatures, living on a small blue planet, orbiting an ordinary star in a galaxy among billions. And yet, we've managed to map the universe. We've built instruments that can detect the afterglow of creation itself. We've drawn a picture of space so enormous that our minds can barely contain it. From measuring the flicker of starlight to capturing the birth of galaxies billions of light years away, humanity has stretched its reach to the edge of the cosmos. And every time we look further, we realize there's still more to see. But as much as we've discovered, we've also uncovered new mysteries. The more precisely we measure the universe, the more questions appear. Why is it expanding faster than expected? What is the mysterious force pushing galaxies apart? Where does the universe actually end? Or does it ever end at all? In the next chapter, we'll face one of the biggest mysteries of all: dark energy and dark matter. The invisible forces that make up 95% of the universe and yet remain completely unseen. So stay tuned, and if you haven't already, subscribe now. Because what you're about to learn next will make you question everything you know about reality itself. Have you ever wondered if we could see everything in the universe, every planet, every star, every galaxy, would that be everything that exists? What if I told you everything we can see, all the stars, planets, and galaxies, makes up less than 5% of the universe? That means 95% of everything around us is invisible, not because it's far away, but because it doesn't interact with light at all. Before we uncover this hidden side of reality, make sure to subscribe to this channel, because what you're about to hear is not science fiction. It's one of the greatest mysteries in modern science. When we look up at the sky, we see the light of countless stars. Galaxies sparkle like cosmic cities, filled with billions of suns. For centuries, we thought this light was the whole story, that what we see is what exists. But in the 20th century, scientists began to notice something strange. The visible matter, stars, gas, dust, wasn't enough to explain what they were observing. It all began with a woman named Vera Rubin, an astronomer who studied the motion of stars inside galaxies. She discovered that stars on the outer edges of galaxies were moving too fast, far faster than gravity should allow. According to Newton's laws, galaxies should spin slower as you move away from the center, much like how planets orbit the sun. But that wasn't happening. Something invisible was holding those stars in place. Something with mass, but not with light. Rubin's discovery shook the foundations of astrophysics. It meant that most of a galaxy's mass wasn't made of stars or gas, but something completely unseen. She called it dark matter. Dark matter doesn't emit light. It doesn't reflect it. It doesn't absorb it. It's completely invisible, yet its gravity shapes the universe itself. We can't see it directly, but we can see its fingerprints everywhere. It holds galaxies together, bends light from distant stars, forms a kind of invisible web connecting everything in the cosmos. Scientists began mapping the distribution of galaxies across space, and what they found was astonishing. The universe wasn't a random scattering of stars. It had structure. Galaxies weren't floating in isolation. They were arranged along massive filaments of invisible matter, like pearls on a cosmic thread. Between those threads were enormous voids, empty spaces with almost nothing inside. This entire structure, the cosmic web, is shaped by dark matter. Imagine for a moment that the universe is a gigantic sponge. The filaments are made of dark matter. The galaxies are tiny bubbles of light stuck along its surface. Without dark matter, this web would collapse, and galaxies like ours could never have formed. But what exactly is dark matter? That's the question scientists have been trying to answer for decades, and it's still one of the biggest mysteries in physics. There are many theories. Some think dark matter might be made of unknown particles called WIMPs, weakly interacting massive particles. Others believe it could be made of ECNs, or even tiny black holes scattered across the universe. But despite thousands of experiments from deep underground labs to massive detectors in Antarctica, no one has ever directly observed a single particle of dark matter. Think about that. We've built machines that can detect neutrinos passing through solid rock. We've measured gravitational waves rippling through space-time itself. But the thing that makes up most of the universe still hides from us. It's like trying to understand a symphony when you can only hear one instrument. The rest of the orchestra is there, silent, invisible, but controlling the rhythm of the universe. For years, scientists thought that dark matter might be the missing piece of the cosmic puzzle. But then, another even bigger mystery appeared, something that made the universe not just stay together, fly apart. In the late 1990s, two teams of astronomers were studying distant exploding stars, Type Ia supernova, to measure how fast the universe was expanding. They expected to find that the expansion was slowing down due to the pull of gravity. But what they discovered shocked everyone. The expansion of the universe was accelerating. Some unknown force, was pushing galaxies apart faster and faster. It wasn't gravity, it wasn't matter. It was something entirely new. They called it dark energy. Dark energy is even more mysterious than dark matter. It makes up nearly 70% of the universe, yet we have no idea what it actually is. We only know what it does. It causes the universe to expand faster over time. To visualize it, imagine blowing up a balloon. At first, it expands slowly. But then, the more it stretches, the faster it expands, as if the rubber itself is being powered by an unseen force. That's our universe right now, expanding faster every second, driven by a cosmic pressure we can't see or touch. Some scientists believe dark energy might be a property of space itself, the cosmological constant Einstein once proposed. Others think it could be a new field, like gravity or electromagnetism, that fills the entire universe. But whatever it is, it's rewriting the fate of everything. If dark energy continues to accelerate the universe, one of three things could happen. Scenario 1, the Big Freeze. Galaxies will move farther and farther apart. Stars will burn out. Planets will freeze. Eventually, even atoms will stop vibrating. The universe will become cold, dark, and lifeless, an eternal silence. Scenario 2, the Big Rip. If the expansion keeps speeding up, there might come a point where it tears apart everything: galaxies, stars, planets, even atoms. Space itself could rip apart, ending the universe in a violent stretch of infinity. Scenario 3, the Big Crunch. Or maybe, someday, gravity will win. The universe might slow down, stop expanding, collapse back into itself, returning to the dense, hot point where it all began. The Big Bang all over again? We don't know which of these is true, but every new discovery brings us a little closer. Now here's the most poetic part. All of this dark matter, dark energy, expansion of the universe tells us something profound about our place in existence. We live in a cosmos that is mostly invisible. Everything we know, the stars, the galaxies, atoms that make up our bodies, are just ripples on the surface of a dark, endless ocean. It means that what we call reality might only be a small window into something much deeper. We see the light, but we live in the dark. Scientists are still trying to find answers. They're building instruments like the James Webb Space Telescope, the Vera Rubin Observatory, and the Euclid mission, all designed to map the unseen universe with unprecedented precision. These telescopes will look not just at stars and galaxies, but at the space between them, searching for the fingerprints of dark matter and the subtle tug of dark energy. In laboratories deep beneath mountains, physicists are hunting for the faintest signals, a tiny flash of light, or a whisper of energy that might prove dark matter exists. And cosmologists are using supercomputers to simulate the birth and evolution of the universe, testing billions of possibilities. The answers may not come soon. But that's the beauty of science. The more we discover, the more mysterious the universe becomes. So next time you look at the night sky, remember this. What you're seeing is just the tip of the iceberg. Behind every star, beyond every galaxy, lies an invisible cosmos, a realm of dark forces shaping everything we know. We are creatures made of light, living in a universe made of shadow. And yet somehow, we've learned to see the darkness. In the next chapter, we'll explore how this mysterious universe began, from the first instant of the Big Bang. When time, space, and matter came into existence, we'll travel back to the very birth of everything. So don't forget to subscribe, because what comes next will take us to the moment before light itself was born. Have you ever wondered, how did everything begin? Not just the stars or galaxies, but time itself, space itself, every atom, every ray of light, even the laws of physics. There was a time when there was nothing. No matter, no light, no sound, no up or down, no before or after. And then something happened. In a fraction of a second, the universe was born. Before we travel back to that moment, the first instant of existence, make sure to subscribe to this channel. Because what you're about to hear is not just a story of science, it's the story of everything. Billions of years ago, before the stars, before galaxies, before time itself, there was only emptiness. But even that word, emptiness, doesn't quite fit. There was no space to be empty in. There was simply nothing. Then, suddenly, from that nothingness. Something appeared a point smaller than an atom, yet containing all the energy that would ever exist. That point didn't explode in space. It became space. It didn't expand into the universe. It was the universe expanding. This moment, this birth of space, time, and matter is what we call the Big Bang. At first, the universe was unimaginably hot and dense. Temperatures reached over 1 trillion degrees, so extreme that atoms couldn't even form. Instead, there was a swirling sea of energy, pure, chaotic, and filled with tiny particles popping in and out of existence. Quarks, electrons, photons, everything danced in a violent storm of creation. Within the first second, forces began to separate. Gravity, electromagnetism, and the nuclear forces all emerged from a single unified energy. And within minutes, protons and neutrons joined together to form the first atomic nuclei, mostly hydrogen and helium. These were the building blocks of everything, the raw material for stars, planets, and life. The universe kept expanding and cooling. After about 380,000 years, it became cool enough for electrons to join those nuclei, forming neutral atoms for the first time. And suddenly light could travel freely. That light still exists today. We can still detect it. It's faint and stretched by billions of years of expansion. It's called the cosmic microwave background radiation. When scientists point sensitive radio telescopes into the dark sky, they see this ancient light everywhere, a soft afterglow from the birth of the universe. It's the oldest photograph ever taken, a snapshot of the universe when it was just a baby. But here's something fascinating. The Big Bang wasn't really a bang. It wasn't an explosion that happened at one point in space. It was an expansion of space itself. Everywhere was the center. Even now, as the universe grows, every point in space is moving away from every other point. That's why no matter where you are, Earth, Mars, or a galaxy 10 billion light years away, it always seems like everything else is moving away from you. Because space itself is stretching. Those first stars were massive, short-lived, and powerful. They burned their hydrogen into heavier elements like carbon, oxygen, and iron, the ingredients for everything we know. When they died, they exploded as supernova, scattering those elements into space. And from that cosmic dust, new generations of stars and planets were born. You, me, the Earth, the air we breathe, all made from the ashes of those first stars. As the famous astronomer Carl Sagan said, "We are made of star stuff." But here's the real question. If the Big Bang created everything, what caused the Big Bang? That's where the mystery deepens. According to Einstein's theory of general relativity, time and space are intertwined. So if time began with the Big Bang, then there was no before it. Asking what came before the Big Bang is like asking what's north of the North Pole. The question itself breaks down. Still, scientists have theories. Some suggest that the Big Bang wasn't the beginning, but a transition. One universe collapsing and rebirthing is another. Others propose that our universe is just one bubble in a vast multiverse, where countless universes are constantly forming and fading away. Each bubble could have different physical laws, different constants, even different versions of reality itself. It's possible that the Big Bang was not a one-time event, but just one heartbeat in an infinite cosmic cycle. Let's talk about something called cosmic inflation, one of the most mind-bending ideas in physics. According to this theory, in the first trillionth of a second after the Big Bang, the universe expanded faster than the speed of light. In that instant, a region smaller than an atom grew to the size of a galaxy. And that rapid inflation smoothed out the universe, explaining why everything today looks uniform and balanced on a large scale. The evidence for this is found in the cosmic background radiation. Those tiny ripples and patterns we see are the frozen echoes of that inflationary burst. It's like seeing the fingerprints of creation itself imprinted across the sky. But perhaps the most profound part of the Big Bang story isn't scientific, it's philosophical. Because it forces us to face the ultimate question. Why is there something instead of nothing? Everything, galaxies, atoms, life, consciousness, all emerged from a single moment of unimaginable energy. And yet, no one knows why that moment happened at all. Some physicists think the universe might have created itself out of quantum fluctuations, energy randomly appearing from the vacuum of nothingness. Others believe there may be a deeper cause, something beyond our comprehension, beyond even the laws of physics. But whatever the reason, one thing is clear. We exist because the universe found a way to begin. Now, look at where we are today, to 13.8 billion years later. The universe has grown vast and cold. Stars burn and die. Galaxies collide and merge. New worlds form from the ashes of the old. And somewhere, on a small blue planet, orbiting an ordinary star, life looks up and asks, how did this all begin? That question, that curiosity, is the same spark that began it all. Maybe the universe created us not by accident, but because it wanted to know itself. We are the universe made conscious, looking back at its own beginning. So, the next time you gaze at the night sky, remember, every star you see, every particle of your body, every breath you take, all of it came from that one singular moment. The Big Bang didn't just create the universe, it created you. In the next chapter, we'll journey forward from the birth of the universe to its distant future. We'll explore how the cosmos might end. Will it freeze, collapse, or tear itself apart? The story of creation is only half the story. The end of everything is waiting to be told. Have you ever watched a balloon being inflated? As air fills it, every point on the surface moves away from every other point. Now, imagine the universe as that balloon, but instead of air, it's filled with space itself. Everything, galaxies, stars, planets, is being carried apart as space expands. This is not a theory anymore, it's a proven fact. The universe is expanding. And not just expanding, it's accelerating. The first clues came in the 1920s when a man named Edwin Hubble, working at Mount Wilson Observatory, made a discovery that changed everything. He studied the light coming from distant galaxies and found something strange. Their light was stretched out, shifted towards the red end of the spectrum, what we now call the red shift. This red shift meant one thing: those galaxies were moving away from us. And not just a few of them, all of them. The further away a galaxy was, the faster it seemed to move. It was as if space itself was stretching like an elastic fabric. That was the moment humanity realized. The universe is not static, it's alive, it's growing. At first, scientists thought that gravity, the great cosmic puller, would eventually slow down this expansion. After all, every galaxy attracts every other galaxy. Over time, maybe the universe would stop expanding and start collapsing back in on itself, a concept called the Big Crunch. But then, something happened that nobody expected. In the late 1990s, two teams of astronomers were studying distant exploding stars type Ia supernova. These supernovae are like cosmic beacons that shine with predictable brightness. By measuring how bright they appear, scientists can tell how far away they are. What they discovered shook the scientific world. The light from these distant supernovae was fainter than expected, meaning they were farther away than they should have been, if the universe's expansion was slowing down. The universe, it turned out, was expanding faster and faster with time. Some invisible force was pushing galaxies apart, stronger than gravity itself. They called it dark energy. No one knows exactly what dark energy is. We can't see it, touch it, or measure it directly. But we know it's there because its effects are everywhere. Dark energy makes up about 68% of the entire universe. Dark matter, the invisible stuff holding galaxies together, makes up another 27%. And everything we can actually see, stars, planets, gas, dust, even us, makes up less than 5% of reality. Think about that for a moment. Everything we've ever known, every discovery, every image from Hubble or James Webb represents just the tiniest fraction of what's truly out there. It's like standing on a beach, looking at a single grain of sand and calling it the world. Scientists have tried to explain dark energy in many ways. Some think it's the cosmological constant, force Albert Einstein himself once proposed, then dismissed, and which now seems to make sense again. Others think it might be a new kind of energy field that fills the universe, or even the geometry of space itself changing with time. But the truth is, we don't know. And maybe, We're not meant to. Imagine this. In 100 billion years, galaxies will have moved so far apart that their light will never reach us again. Future civilizations, if they exist, will look at the night sky and see nothing beyond their own galaxy. They'll never know the universe once looked so vast, filled with countless galaxies. The cosmos will grow dark and silent. But for now, in this brief moment of cosmic history, we can still see it. We can still measure, imagine, and dream about it. Dark energy might be a mystery, but it's also a reminder that there's so much left to discover. We are living in an age when humanity can look billions of light years away, trace the birth of stars, and map the structure of the entire universe. And yet, the deeper we look, the more we realize how little we truly know. Perhaps that's what makes the universe so beautiful, not just its size, but its mystery. So as we continue this journey into the cosmic unknown, remember, every discovery leads to a new question. Every answer reveals another secret. And in that endless search lies the very essence of being human. Because maybe the universe isn't just expanding outside of us. Maybe it's expanding within us too. Imagine standing under the night sky, not as it is now, but as it will be billions of years from today. The stars are fewer, the sky is darker, and the silence feels endless. The universe, once filled with the music of creation, now whispers only echoes of what it once was. This is the story of the universe's future, the story of everything, fading away. But before we talk about how it might all end, let's take a step back and remember how it began. We've seen how the Big Bang sparked the birth of space and time, how galaxies formed from clouds of hydrogen and dust, how stars lit up the darkness and gave birth to worlds. But what happens after creation? What happens when the fire starts to die and the light begins to fade? Will the universe expand forever, growing colder and emptier until not even light survives? Or will gravity pull it all back, crushing everything into one final, unimaginable collapse? Or maybe, just maybe, the universe will tear itself apart, piece by piece, in a violent end beyond comprehension. These are the great questions of cosmic destiny. The expanding universe, a future without limits. We know now that the universe is expanding, not just slowly, but faster every moment. Distant galaxies are racing away from us, their light stretched thin by the stretching of space itself. This expansion is driven by something mysterious, something we call dark energy. If dark energy continues to act the way it does today, the universe will keep expanding forever. Every billion years, galaxies will drift farther apart, and the night sky will grow lonelier. Right now, when we look through telescopes, we see billions of galaxies, each filled with stars and planets. But in the far future, most of them will vanish from view. The light from those distant galaxies will be stretched so much that it will never reach us again. It will fade into invisibility. The only thing left visible will be our own local group, the small cluster of galaxies that includes the Milky Way and Andromeda. And then, even those galaxies will change. The Great Collision Milky Way and Andromeda. In about 4 billion years, our Milky Way galaxy will collide with its neighbor, the Andromeda galaxy. It sounds violent, but in truth, it will be more like a dance. Both galaxies will pass through each other, their stars rarely colliding because of the vast distances between them. Gravity will twist and shape them into something new. A single, massive galaxy astronomers have already named Milkomata. Inside that giant new home, the night sky will look breathtaking, billions of stars, glowing brighter than ever before. But it will also be a sign the universe is changing, evolving toward a future we can barely imagine. The death of the stars. After the collision, time will stretch on, billions and billions of years. Stars will live, burn, and die. But there's a limit. Even stars cannot shine forever. The biggest stars, those burning blue and white, will die first, exploding into supernova, leaving behind black holes and neutron stars. Smaller stars like our sun will live longer, about 10 billion years in total, but they too will eventually die. When the sun runs out of hydrogen fuel, it will swell into a red giant, swallowing Mercury, Venus, and maybe even Earth. Then, after a final breath, it will shed its outer layers and leave behind a small glowing core, a white dwarf. For trillions of years, these white dwarfs will slowly cool, fading into darkness until they become cold, black remnants called black dwarfs. At that point, the universe will no longer have new stars forming. The great cosmic factories, the galaxies, will fall silent. This will mark the beginning of the Stelliferous era's end and the dawn of the degenerate era. An age of fading light, the age of darkness. Imagine the universe then, countless black dwarfs, neutron stars, and black holes scattered across a dark, frozen void. Galaxies that once glowed with billions of suns will now be invisible. In this distant future, temperatures will fall near absolute zero. Planets, if any remain, will drift aimlessly through the dark, no longer warmed by any sun. Even atoms may begin to decay. Protons, the building blocks of matter, might disintegrate over unimaginable timescales. If that happens, the universe will become a thin mist of subatomic particles, forever expanding into nothingness. But if protons remain stable, then black holes will rule the cosmos. The reign of black holes. Black holes are the ultimate survivors of the universe. They're what's left after the death of the most massive stars, regions of space so dense that not even light can escape. Over time, galaxies will fall apart, and black holes will drift alone through the cosmic darkness. They will swallow anything that comes close. Rogue stars, gas clouds, even other black holes. When galaxies like Milkomeda fade, supermassive black holes at their centers will remain silent guardians of a dead universe. But even black holes aren't eternal. According to Stephen Hawking, black holes emit tiny amounts of radiation known as Hawking radiation. It's a slow process, but over trillions upon trillions of years, this radiation will cause black holes to lose mass and eventually evaporate completely. When the last black hole dies, the universe will truly enter its dark era, a time when not a single source of light or heat remains. The Big Freeze, a universe of silence. This is what most scientists believe is the universe's ultimate fate, the Big Freeze, also called heat death. In this scenario, the universe expands forever. Galaxies drift apart. Stars die. And energy spreads so thin that nothing can happen anymore. No stars to shine. No atoms to bond. No life to think or feel. Entropy, the measure of disorder, reaches its maximum. Everything becomes evenly cold, evenly dark, evenly empty. It's a quiet, peaceful, but deeply haunting ending. A universe not destroyed by violence, but by exhaustion. The Big Crunch, the universe collapsing back. But not all scientists agree with this ending. Some believe that one day the expansion might slow down, stop, and reverse. If the gravitational pull of all the matter in the universe is strong enough, it could eventually overcome dark energy. The galaxies would stop moving apart and begin to fall back together. The night sky would grow brighter again as galaxies rushed toward each other. Temperatures would rise, radiation would increase, and everything would collapse back into a single point, just like the moment before the Big Bang. This is called the Big Crunch, the opposite of the Big Bang. And perhaps after that collapse, a new Big Bang could happen again, a cyclic universe, endlessly reborn from its own ashes. If that's true, then maybe creation and destruction are not opposites, but two sides of the same coin, an eternal rhythm of existence. The Big Rip, the most terrifying end. There's one more theory, darker and more violent than all the rest. If dark energy keeps getting stronger, it could eventually overpower every force in the universe, even gravity, even the atomic bonds that hold matter together. First, galaxies would be torn apart. Then stars, planets, and eventually even atoms themselves would be ripped apart by the accelerating expansion of space. This is called the Big Rip. In the final seconds, the very fabric of space-time would shatter. There would be no time, no place, no matter, just pure nothingness. It's the most dramatic ending science has ever imagined. The universe destroying itself not with fire or ice, but with expansion gone mad. The end, or a new beginning. Each theory, Big Freeze, Big Crunch, Big Rip, tries to answer the same question. How does existence end? But maybe the real answer is something beyond our understanding. What if our universe is just one of countless others, a bubble in a vast multiverse, where new universes are born from the death of old ones? What if time itself is just a cycle, looping endlessly, with creation and destruction forever linked? If so, then the end of our universe might not be the end of everything, just the beginning of something new. The human perspective. When we talk about the end of the universe, it's easy to feel small, like nothing we do matters in this vast cosmic timeline. But maybe that's not the right way to see it. Think about it. In a universe 13.8 billion years old and 93 billion light years wide, we exist conscious, curious, aware. We can look at the stars and understand what they are. We can measure galaxies, predict cosmic futures, and imagine what eternity might look like. That's not insignificance. That's a miracle. The atoms that make you were once part of ancient stars. When the universe began, those atoms didn't know they would someday think, feel, or dream. But now, through you, the universe has found a way to look back at itself, to ask, where did I come from? And where am I going? So even if everything ends one day in ice fire or darkness, our existence has already changed the story of the cosmos, because we are the universe, made self-aware, and maybe that's enough. The final thought. If the universe is destined to fade into darkness, perhaps the real light lies not in the stars, but in the minds that dared to understand them. Because long after the last galaxy fades, long after the final black hole evaporates, the echo of our curiosity, our wonder may still ripple across the void. And who knows? Maybe somewhere, somehow, another universe will rise, and in it, another being will look up and ask the same timeless question. How big is the universe? And so, the story begins again. For billions of years, the universe has been expanding quietly, endlessly, almost like a heartbeat that never stops. And here we are. It's a tiny species on a pale blue dot, trying to understand what this infinity truly means. When we gaze into the night sky, what we really see is not the stars, but the past, billions of years old. Every photon that touches our eyes has traveled across unimaginable distances, crossing the void between galaxies just to reach us. And in that single moment, we become witnesses to eternity. Science tells us that the universe is about 93 billion light years across, but even that number feels like an illusion. Because the more we discover, the more the universe stretches beyond what we can measure. It's as if the cosmos is whispering, you will never reach the edge because the journey itself is infinite. But maybe that's the beauty of it. Maybe the universe was never meant to be understood completely, but to remind us how small, and yet how extraordinary we truly are. Every atom in our bodies was once forged in the heart of a dying star. Every breath we take carries the memory of something ancient, something cosmic. So when you look at the night sky, don't just see stars. See your own origin story, because you are not in the universe. You are the universe, thinking about itself. Humanity has come far from drawing constellations in the sand to sending telescopes beyond the solar system. And yet, we've barely taken the first step. Somewhere beyond the horizon of what we know are galaxies we will never reach, and mysteries we will never solve. But that's okay, because wonder itself is infinite. Think about this. Every single human who ever lived, every love story, every dream, every war, every creation, all happened on a single speck of dust floating in a sunbeam. And yet, that little world gave birth to minds capable of imagining the entire cosmos. Isn't that miraculous? The question, how big is the universe, might never have a final answer. But maybe the real question was never about size. Maybe it was about perspective, about realizing that even in our smallness, we hold something infinite, curiosity. Curiosity is what drives us to explore, to build, to ask questions that have no answers. It's what makes us human. And as long as that spark stays alive, You'll always keep reaching for the stars. So the next time you look up at the sky, remember this. You are part of something vast, something that existed long before you and will exist long after. But in this short moment, between the birth and death of stars, you get to wonder. You get to feel. You get to be aware. And that is what makes you truly infinite.